Say you wanna be shorty's gonna be a thug. Was a nice middle class nigga, but no one knew the evil he do when he got a little bigger. Good off the final blade.
So second derivative test. Again, I'm gonna write that our important formula here is the discriminant, which is d is equal to fxx times fyy minus fxy squared. Okay, so this thing here, so I'm going to write the sine of d, sine of capital D. So capital D is the discriminant. That's the entire thing, the entire result you get. Okay, and then we have sine of fxx, okay, at that point, AB. All right, and then we have, lastly, what is the type of critical point? Critical point. Okay, so if we have this chart going on, so let's say we have sine of D. The first option was if it's positive. Okay, so D is positive, and then what if fxx is positive? Then that means we have concave up in all directions, right? So that means we have a local minimum. Okay, now what if we have a positive here but a negative here? That means that we must have a negative in both directions, so concave down in both directions. So that implies that we're at a local maximum. We're at a high point, right? Because everywhere else we go would be downwards. Okay, and then let's say D is negative. All right, so that means that fxx and fyy don't agree. They're opposite signs. So that means that we're automatically at a saddle point. Saddle point. So the sign of fxx doesn't really matter, okay? We just know that whatever the sign of fxx is, fyy is the opposite of that, okay? And then finally, if the sign of D is 0, or if we just get 0 for that, then that means that the test is inconclusive. Inconclusive. Okay, and again, the sign of fxx does not matter. All right? Okay, now on to the next thing. Okay, so now we're going to go over a little bit of global, also known as absolute, extreme values. Okay, and again, extreme values just means maximum or minimum values. There we go. Okay, so we're going to say that we're going to let our f of xy be a continuous function, first of all. So a continuous, I'll abbreviate, continuous function on a closed, this is important, a closed, meaning it includes endpoints, closed, bounded, so it has a boundary, right? It doesn't go on forever in any direction. Bounded domain, D, domain, we're going to call it capital D. Don't confuse that with the discriminant, okay? And this is in R2, okay? R2 meaning the XY plane, or one plane, right? Okay, so in 2 dimensions, then we have that, sorry, not 2, number one, then f of xy takes on a minimum and maximum value, a minimum and max value on our domain D, okay? And furthermore, number 2, those extrema, the minimum or maximum, minimum and maximum, extrema, min slash max, they must occur. So they occur either at a critical point again being where the first derivatives are both either equal to 0 or do not exist. Okay, so at critical points, at a critical point on the interior, it's called on the interior, or basically the inside, right? Interior of D, or it could be at points on, normal points, on the boundary of D. So on the endpoints, right? They call it boundary because it's not just 2 endpoints anymore, but on the boundary of D. It could just be like a border, like a fence, okay? So this is basically kind of like a throwback to single variable, where you remember to check the endpoints, remember that? So on like on a domain. So now that we have to, just consider or check those boundary points over the domain and compare it. So basically what we would do is find critical points. So we find critical points, okay? And once we find those critical points, we're just going to plug them into, plug into original function, original like f of x, f of x, y, or something, or whatever function you may have. Okay, so original function. And then we're going to compare those values, those function values, those values with the ones you get, ones you obtain, I'll say, ones you obtain or that are resultant from plugging in endpoints, plugging in endpoints, or I'll call them boundary points, okay? Boundary points. So we basically just have to check everything on the boundary, okay? All right, so that's basically it. I will be going through examples, all the kinds of different topics that we have discussed in this concepts video, so you don't have to worry too much about that. So I hope that helps, and good luck on your homework.
Shorty's gonna be a thug, straight from the hall to the pen. An adolescent nigga standing way higher than 6 feet 10. He carried weight like